Greetings colleagues, in this short video presentation I would like to talk about an important weather phenomena, the cloud ceilings, its importance to the pilots and the ways how cloud ceilings are determined and reported. Let's say you are approaching your destination and you dial the ATI's frequency to listen to the current weather. The weather report reads the clouds as broken and ceilings at 5,500 feet. You need to land under V4. Now, as I said at the beginning, let's have a look on how ceilings are reported and why it's important to know how they are measured. At Honey Weather Reporting Station, a portion of the sky is used to weather reporting. This portion of the sky is called the celestial dome. Celestial dome is part of the sky that's visible to a human observer above all natural obstructions, including hills and trees. If there is a building which restricts the observation, they will try to see or estimate the sky condition on the other side of the building. Important to know that celestial dome only apply to observation stations with human observers. An important part of the weather report is related to the sky condition. One important phenomenon related to the sky condition is the ceiling. Ceiling is defined as the height of the lowest layer of the clouds above the surface that are either broken or overcast but not thin. Based on that definition, cloud's ceiling is only determined if there is broken or overcast. Since weather reports either meter or TAF does not include the term thin, anything reported as broken or overcast is the ceiling. Now, let's see how broken or overcast is measured. By something called octals. Octals are 8 equal segments of the sky. If 5 to 7 segments are covered by clouds, it's reported as broken. If all 8 segments are covered by clouds, it's reported as overcast. Now, how cloud altitudes are measured? Very important to know. There are a variety of methods that reporting stations use to report the cloud altitudes. The most common ones are: the first method is the human observers. ETC personnel are trained to accurately estimate the cloud types and altitude. If meteor report does not contain the phrase auto, the cloud type and altitude is estimated by a trained ETC personnel who physically walk outside and have a look on the sky. The major problem with humans' observation is the packing effect, where clouds farther away laterally look more packed together. The second method is by using light beam ceilometers. In this method, a light beam is placed at a position away from the station and directed upward. A measurement device at the station senses when the light disappears into the cloud. Using trigonometry, cloud altitudes can be recorded. In the last and third method of determining cloud altitude is by using cloud height indicator, or CHI. The cloud height indicator works same as a radar. A device sends a radio beam and measures the time the beam hits cloud base and return back. The going and coming back time is used to determine the cloud base or altitude. CHI is mostly limited to 1 to 1,000 feet of altitude. CHI is the most common cloud measurement device at most airports, and by using advanced technologies, it will soon be able to measure the cloud bases up to 24,000 feet. So, why it's important for the pilots? Clouds are always reported by the weather stations. In fact, in feet above the ground level, or AGL. So when we plan for takeoff or arrival, pay attention to cloud reports to know how clouds are high around us. This will help us to determine at what altitudes we should flight to maintain cloud separation requirement. To determine the cloud height in feet above mean sea level or MSL, we should add the elevation of a weather reporting station to the reported cloud heights. The surface observation of clouds always has some limitations. They are limited by location and time, but if you understand how clouds are reported by weather stations, it will be easier to understand how they will affect our flight.